In this video, we're going to look at the derivative of trig functions. And so if you think back to what we've done before with trigonometric equations, we've looked at their graphs and we know what their domains and ranges are, and we know some basic properties on those. In addition, if we think back to what we've done with derivatives, we have looked at a graph of a function and seen how to derive the derivative from that graph. And so we're going to use that method to find the derivative of our trigonometric functions and then use the properties to get some of the other ones. Now, if you look in most textbooks, they will actually go through a formal definition of a proof, and I encourage you to read through that. But for our purposes, let's look at these and try to intuitively figure out what the derivative looks like. Okay? So here we've got two of our basic trig functions, y equals sine of x and y equals cosine of x. And if we kind of think about what the slope is doing as we go through these curves, well, we can see that I start out with something positive, and it's kind of steep, and as I move along the curve, it becomes less and less positive and reaches a slope of 0. And then from there, it's going to start decreasing, and it becomes less decreasing as we move, and then again goes to 0, and then starts increasing again. Okay? So if we look at that, basically what it says is, again, we start with a positive slope that looks like it's going to decrease for a while, and then at some point in between it's going to hit 0. Then it starts decreasing. It's going to reach kind of the furthest point where it's decreasing, and then it starts increasing again. Okay? And then from there it's going to hit 0 and then become positive again. And so here we can see, if we look at kind of the orange curve there, we see that y prime is going to be cosine of x. Okay? And we can do the same thing for the cosine function. If we start with the cosine function, we can see that the slope starts and ends at 0. It's going to start out decreasing, so it's going to start negative, and then it's going to keep decreasing, so stay negative. It's going to slowly go to 0, and then after it's 0, it starts increasing again, reaches kind of a high point, and then slowly becomes less positive to 0. Okay? So here, if we're looking at our curve, again, we start at 0. It's going to go negative, reach a low point, come back up, hit 0, and then it starts increasing till we reach some high point, and then slowly becomes less positive to 0. And so if we look at that curve, we can see that the derivative looks like negative sine of x. Now, using our trigonometric properties, we can use these two derivatives to come up with the derivatives for the other 6 trig functions, or the other 4 trigonometric functions. Okay. So, for example, if we look at the secant of x, okay, secant is the same as y equals 1 over cosine, and from our quotient rule, we know that we can take the derivative of that by taking the derivative of the top times the bottom minus the top times the derivative of the bottom, which we just found was negative sine of x, all over the bottom squared. And so simplifying these, what do we mean by simplifying trig functions? Well, it means I want to get it back in terms of basic trigonometric functions, so sines, cosines, tangents, etc. And I want no powers if possible. Okay? In some cases you're not going to be able to simplify the powers down, but if you can, you certainly want to. So here, if I look, I can think of this as sine of x over cosine squared of x, which we can think of as sine over cosine times 1 over cosine. And if we simplify that, we can see that y prime is going to be tangent of x, secant of x. or how you'll usually see it written, the derivative of our secant function is the secant tangent. Okay. Likewise, if we look at the reciprocal of our sine function, so if we look at the cosecant, we can do the same type of thing. So again, we can use our quotient rule. So y prime will equal derivative of the top times the bottom minus the top times the derivative of the bottom, which again we saw derivative of sine is just cosine, all divided by sine squared. Okay, same thing, we want to simplify that. So this is going to look like a negative cosine of x over sine squared of x, which again we can break up into a negative cosine x over sine x times 1 over sine x. And so looking at that, this says that y prime is going to be the negative cotangent cosecant of x. Okay. Or again, just rewriting that, derivative with respect to x of our cosecant of x is going to be the negative cotangent x cosecant x. We can also look at our tangent and our cotangent functions. So again, we can think y equal to tangent of x, which we can think of as sine of x over cosine of x. Okay. Here again, if we use our quotient rule, we can see that dy dx, just to give you a slightly different notation, derivative of the top, which was cosine x, times the bottom, minus the top times the derivative of the bottom, all divided by our bottom squared. Okay. Again, we want to simplify. Here we can see that cosine times cosine is a cosine squared. Negative sine and negative sine is plus a sine squared, all over cosine squared. On the top, you should recognize your Pythagorean identity. And then from there, we can rewrite it as a basic trig function. Okay. So there's our derivative. dy dx of tangent x is going to be our secant squared. Okay. And of course, the last one to look at is our y equal cotangent of x. So again, we can think of this as cosine x over sine x. You can also think of it as 1 over tangent. You can also think of it as your secant over cosecant. Okay. Here again, if I go back to cosine and sine, the idea is as long as you know those two derivatives, you can find any of the other 4. Okay. So our dy dx here will look like our quotient rule again. So derivative of the top, which is a negative sine x, times the bottom, minus the top times the derivative of the bottom, all over the bottom squared. Simplifying, we can see we're going to get negative sine squared x minus a cosine squared x all over sine squared. Here, be very careful. Some people look at this and say, oh, double angle. No, this is still your Pythagorean identity. It's just you've got to factor the negative 1 out. So from there we can see negative 1 over sine squared x. Again, when we put that back in terms of a basic trig function, we get our negative cosecant squared x. Okay? And so, just to list up all of our derivative properties, the ones that you are going to need to know, derivative with respect to x of cosine x is going to be negative sine of x. Derivative with respect to x of sine x is cosine x. These are the two you definitely need to know for exams. The others are useful to know, but again, if you don't remember them, you can derive them. So if I'm looking at the secant, we get the secant tangent. If I have the cosecant, we get the negative cosecant cotangent. If we get the tangent, the derivative is going to be the secant squared. And if we get the cotangent, it's going to be the negative cosecant squared. Okay, so there are your derivatives of your 6 trigonometric functions.